right, grade 9, we are done. The part of chapter 9, we are in chapter 9, Schneider. Sorry, I couldn't resist. That was mean. I don't mean it to be. So we're in chapter 9. We have finished the part of chapter 9 that deals with scatter plots and graphing them and doing lines of best fit. Yay. It's not my favorite thing to do. We are moving on to the part of the chapter that deals with probability. If you look in your textbook, what you will notice is that the distance from where we did section 9.3, that was on page 334, and we're jumping all the way over to page 348. There are all kinds of sections in between that are those what I like to call extra sections. Were we in class together, we would actually do 2 or 3 of those sections together. It's not that there's anything really important in there. There's just a couple of little interesting things that we do together, like we play some games and stuff together. But it's kind of hard to do this way. So we're just going to skip them. Again, there's nothing, don't worry, you're not missing anything. You won't be like next year going, oh my word, we didn't learn that. That's just not going to happen. Okay, but we are moving into section 9.4, which talks about the probability formula. So we're moving into probability. And it kind of feels like talking about scatter plots and then talking about probability are not really related, but they really all fall under the umbrella of what we would call statistics. All of this is just like the basics, like really, really bottom level basics of probability and statistics. And over the next 4 years, we will slowly build on that until we get into, in grade 12, bell curves and Z-scores and percentiles and things of that nature. But if you don't know this stuff, then all of that is really quite difficult to do. So most people really like the next couple of sections because a lot of it is intuitive. Because we deal with this type of stuff all the time. When we talk about probability, it's always the number of what we call favorable outcomes, the number of things we want to happen over all possible outcomes. And an outcome just means something that could happen. So probability is favorable things, the things you want to happen, and it doesn't necessarily mean it's a good thing. If you're figuring out what is the probability that, I don't know, that a hurricane will hit tomorrow, okay, then a favorable outcome would be a hurricane hitting tomorrow, even though that's not a good thing. In probability, favorable outcome doesn't necessarily equal a good thing. It just means the thing that you're researching, okay? So number of favorable outcomes over the number of all possible outcomes. So when you roll a die, right, there, just a standard one, not one of those fancy ones, just one like this, there are 6 possible outcomes. You could get a 1, a 2, a 3, a 4, a 5, or a 6. That's all there is. There's 6 possible outcomes. And they're all equally likely, unless you have what's called a loaded die, which is one that is weighted in one direction or the other. I actually saw a documentary, believe it or not, on how they make these things, which sounds really boring, but it wasn't a long documentary. It was like, a few minutes long. But they were actually talking about how they make these. It's actually quite complicated because these have to be weighted in such a way so that all possibilities are of equal outcome. If you go to a casino, I'm not recommending that. But if you go to a casino, if you've ever been to Vegas or whatever, the dice that they use, they're actually like under lock and key. And they watch very carefully for people switching dice. And because if I put this in my pocket and pull out my own that happens to be weighted in such a way to give me an outcome I want, that's cheating, right? It's illegal, and you can get into big trouble. So, sorry, my husband just came home. Always when I'm doing grade 9. So, the probability of rolling a 3. The probability of rolling a 3. The probability that I roll this and I get a 3 and I don't have anywhere to roll it. The probability that I roll it and I get a 3, I actually got a 1. The probability that I get a 3 is not 3 out of 6. And sometimes that's what people will tell me, is that the probability of rolling a 3 is 3 out of 6. No, it's not. Number of favorable outcomes. Well, there was only one number 3 on the die, so there was only one favorable outcome out of 6 possible outcomes. All right, so it's 1 out of 6. So what would be the probability of rolling an even number? Well, on the die, a 2, a 4, or a 6 would be an even number. So the probability of getting an even number would be 3 out of 6, which reduces to 1/2. There's actually a 50-50 chance that I will roll an even number. So what would be the probability that I would roll a prime number? So remember, a prime number is one that is only divisible by itself or 1. So 1 is a prime number, 2 is a prime number, 3 is a prime number, 4 is not, 5 is a prime number, 6 is not. So there's 4 numbers on the die that are prime numbers. So there's a 4 out of 6 chance. If the fraction is reducible, you should reduce it. So there's actually a 2 out of 3 chance. So in theory, in a perfect world, for every 3 times I roll the die, 2 of them I would get a prime number. What is the probability that the number I roll is divisible by 7? In other words, I could divide the number that I get by 7. Well, there aren't any numbers on a die that are divisible by 7. So there are no favorable outcomes. So I have a 0. I don't know why I put 7. So I have a 0 out of 6 chance of getting one that is divisible by 7. All right. So if we look at page 348, example 1. Now I'm going to have a problem with example 1 because, and I've said this before, my book is in black and white and some of this is reliant on color, so I'm going to have to cheat and look at the answers. They have a spinner and it says, and a spinner is just like a die, right? Like the chance of you getting it in all the spaces should be of equal size. If they're not of equal size, then it's not the same chance. So for instance, if I had a spinner and half of it was, I don't know, say purple, and then this piece was blue, and this piece was green. Hey, enough! And this piece was green, and I said, what's the probability? What's the probability of you getting a purple? It would actually be 1 out of 2 because half of the circle is purple, right? So whereas the probability of me getting blue, well, it's like 2 of my spaces are purple. And so the probability of me getting blue would actually be 1 out of 4, okay? So make sure that your spaces are equal size, because if they're not, then it throws your probability off. So it says find the probability of each of the following outcomes for the spinner. Express each answer as a percent. So we're going to talk about how you would do that. So what's the probability of you getting a 4 4. Well, based on that spinner, there are 8 sections, so there are 8 possible outcomes. Only 1 4 on the entire spinner. So 1 out of 8 is your probability. Now they said express it as a percent. So what you do is you just divide those. 1 divided by 8 is 0.125. That's a decimal. To change it to percent, you just multiply by 100, which gives you 12.5%. So there's a 12.5% that if you were using the spinner that they provide, you would get a 4. What is the probability that you get an odd number? So again, you have 8 sections. An odd number, well, 7 is odd, 1 is odd, 3 is odd, and 5 is odd. So there are 1, 2, 3, 4 numbers that are odd. So there is a 4 out of 8 chance, which reduces to 1 over 2, which is 0.5, which if you multiply it by 100, there is a 50% chance that you would get an odd number. All right, C is one I want to look at because it says, what is the probability you get a 4 or a 7? That word or is important. If you see the word or in probability, in statistics, or means you really should add. Or means add when it comes to probability. So what is the probability that you get a 4 or a 7? Well, for 4, there's a 1 out of 8 chance that you get a 4. For 7, there's a 1 out of 8 chance that you get a 7. So I've got a probability of 1 out of 8 for a 4 or a probability of 1 out of 8 for a 7. Because it's the word or, it means I'm going to add those fractions, which is going to give me 2 over 8, which reduces to 1 over 4, which is 0.25, which is 25%. Okay? So when you see the word or in probability, it actually means you should add. What is the probability that you're going to get a 9? Well, there is no 9 on the spinner, so it is 0 out of 8 or a 0% chance. You can't get a 9 if it's not there. What is the probability that you will get a number from 1 to 8? Well, all of them are 1 to 8, so there's an 8 out of 8 chance you would get a number from 1 to 8, which is 100%, right? Because 8 divided by 8 is 1, and 1 times 100 is 100. Now, here's the one I can't do, so I'm going to have to cheat. What is the probability that when you spin, it will land on a green section? Well, mine are all shades of gray. But according to the answer, there are 4 green sections. So out of the 8 sections, 4 of them are green. That reduces to 1/2, which in decimals is 0.5. So in percents is 50%. Okay? Okay, so I want to talk about the or a little bit more. So don't tell my husband, but I went through his trail mix and I pulled out, he's got M&Ms in his trail mix. So I pulled out some M&Ms out of his trail mix, and no, I'm not putting them back in. I will eat these when I'm done. And what I did was I just pulled out some that are different colors. And so in my little jar, I have 5 that are orange. I have 5 that are orange. And I have 5 that are green. And I have orange, I did green. I have 1, 2, 3 blue. And I have 2 brown. And I have 3 red. Okay, so those are the different colors and how many I have of each of them. Let me see, orange, green, blue, brown, and red. Yes. So, that means in total, there should be 10, 13, 16, 18. There should be 18 M&Ms in my container. And let me see, I got 2, 4, 6, 8, 10, 12, 14, 16, 18. I have 18 M&Ms. 18 M&Ms does not look like very many in a jar. All right, so I have 18 M&Ms. Now, if I asked you, what is the probability that if I close my eyes and I pulled one out, that it would be blue? Well, there are 3 blue, so there is a 3 out of 18 chance, which would reduce to 1/6. And again, if I change that to decimals, 1 divided by 6 would be 0.17, which is a 17% chance. So there would be a 17% chance that I would get blue. So I'm closing my eyes, I'm pulling one out. Oh look, I got blue. So I fell in that 17%. But what if I change the wording a little bit? And what if I said, what is the probability that I get a brown or a red? Okay, so when I close my eyes and I put my hand in and I pull out an M&M, what is the probability that in my hand I'll either have a brown one or a red one? I'm only doing this once. I'm just putting my hand in and pulling out one M&M. So brown would be 2 out of 18. Red would be 3 out of 18. Because I use that word or, I'm going to add, which is going to be 5 out of 18, which doesn't actually reduce. So 5 divided by 18 is 0.28 when I round it off, because it's 2.77777. So that is a 28% chance. So again, let's see if I can do that. So brown or red, I got my eyes closed, I'm not looking. I'm going to pull one out. What is the probability that it's brown or red? I did not, right? I got green. So when you see the word or, you need to add. That's it. We only have one more section after this. I'm going to eat this. I only have one more section after this, and then we're actually done. So let me let you in on my lesson planning thoughts. So Thursday, we're going to do section 9.5. So I would review on Friday. Monday is Victoria Day, so it's a long weekend. And so Tuesday, we would have a test. So that would be Tuesday, May 19th, we would have a test on Chapter 9, Scatter Plots and Probability. Tuesday, May 19th, 8:30 a.m., we would have a test, Chapter 9, Scatter Plots and Probability. After that, we'll be done. I will upload to you the large project. And let me say again, there is no exam, there is no exam, there is no exam. So there is no exam, but I'm going to send you a project that's going to cover chapters 5 through 9. You will have about 3 weeks to work on it. 1, 2, 3. You will have about 3 weeks to work on it. You will have no other work for me other than to do that. I'm going to say this again. Don't rush it just to be done math. Don't rush it. It is important. It is significant to your mark. I want you to do well on it. Take your time with it. You have until June 5th, okay? So please don't rush it. Don't worry about it. Like, don't let it stress you out. But you know who you are. Those people who like to just rush through, get it done. You don't even check it over. You don't even look it over. You hand it in to me and you end up missing half the questions or something because you didn't take the time. All right. So I want you to make sure that you take your time with it and do your best with it. And that's it. Talk to you again soon.